G'day viewers, in this episode we're going to talk about possible future research which could realise one of mankind's greatest dreams, that is interstellar travel. In previous episodes we revealed the impossibility of faster than light travel, including wormholes. However, we left the door ajar by speculating that element 115 acts as a quantum vacuum inhibitor, which suppresses the Casimir effect. It achieves this via the destructive interference of the quantum vacuum probabilities associated with the virtual photon creation-annihilation process locally, occurring at all points throughout the universe. In our previous episodes, we hypothesised that space-time is 5D, not 4D, as described by general relativity. That is, space-time comprises of 4 spatial dimensions and 1 temporal dimension. This means that our universe is actually a hypersphere. We described the associated 4th spatial dimension as being the dark reservoir of quantum potential energy. Consequently, the dark reservoir of quantum potential energy is the energy source powering the virtual photon creation-annihilation process occurring at all points throughout the universe. You should recall from our previous episodes that we described baryonic matter as evaporating into the dark reservoir of quantum potential energy via graviton radiation. Thus, the law of conservation of energy is satisfied and manifestly observed via the Casimir effect. Therefore, if element 115 acts as a quantum vacuum inhibitor by suppressing the Casimir effect, then the 4th spatial dimension between 2 points will collapse. Consequently, the other 3 spatial dimensions will also collapse because they're connected to the 4th spatial dimension at right angles to it. In other words, by collapsing one spatial dimension, we collapse all spatial dimensions and the distance between 2 points is reduced to nearly zero. Please note that I have chosen my words carefully. I have stated that space-time collapses. It does not form a wormhole. A wormhole is theoretically created by severely bending space-time, not by collapsing dimensions. According to general relativity, space-time becomes so curved that one point literally overlaps another, and we describe this as being a wormhole. This is why the energy required to establish a wormhole is unrealistic. However, the energy required to collapse space-time is trivial by comparison. That is, assuming that the quantum vacuum inhibition process works in the manner we have hypothesized. So, the key to interstellar travel is element 115. Okay, so what does all this mean? Well, I'm trying to communicate to viewers, particularly to younger generation viewers, that if you have a passion for science, engineering and interstellar travel, then you may wish to consider a research career relating to element 115. That is, moscovium. This is not as bizarre as it may seem. Look at the alternative. That is, general relativity requires exotic matter for wormholes. Element 115 has been created on Earth. Exotic matter has not. Element 115 is real. Exotic matter is a fantasy. However, one of the challenges which needs to be overcome is element 115 instability. Solving this problem would need to become your ambition. My expectation is that, with the right minds working on the problem, a stable isotope of element 115 can be theoretically identified within 1 generation. That is, within about 30 years. It would then take another generation to find the money to run the experiment, proving the theory. After this, a 3rd generation would probably be required to identify the quantum vacuum inhibition effect I've talked about. So my expectation is that within 5 to 6 generations, say within the next 200 years, interstellar travel will be a realistic engineering possibility. However, all of this begins now, and it begins with you. If you're a young viewer watching this and the possibility of interstellar travel excites you, please consider a career in science and engineering. Don't get swept away by the materialistic man-made world. Think of the bigger picture. Consider this. It took almost 15 billion years for the universe to create you. In my opinion, you are morally obligated to understand it. Okay, let's now have a look at some of the tools you might need.
The tools you need will be defined by the issue you're trying to solve. Your first challenge will be to solve the element 115 instability problem. In this diagram, we see the island of stability which Bob Lazar has spoken about. In theory, this island contains the solution you'll need to find. You'll need to find the number of neutrons which combines with 115 protons to produce a stable element 115 atom. The wrong solution leads to nuclear instability. The right solution will be driven by nuclear geometry. It'll be your task to find the correct geometric solution. This won't be an easy job. It'll be extremely difficult and may require decades to solve. To make matters worse, you'll need to convince your peers that your theoretical solution is correct. If you can't do this, your theoretical solution will never advance to the experimental stage. The financial cost of synthesizing a stable element 115 atom will be horrendous, so it'll be imperative for you to get buy-in from other scientists. Given the geopolitical climate of today's world, you'll probably also need to navigate a tempest in order to turn your thoughts into reality. Politicians will happily sacrifice you and everyone else for their own personal advantage. We see this happening on a regular basis, so you can confidently expect to encounter great frustration on your journey. However, as bleak as the prognosis sounds, it's about to get much worse. In addition to solving the stability problem, you'll also need to consider the many orders of magnitude problem along the way. Let's talk about this a bit more. In episode 54, we presented the concept of EGM waves. These are the theoretical waves linking the solution to the many orders of magnitude problem with the hypothesized quantum vacuum inhibition effect we associate with element 115. This means that, in addition to the nuclear stability problem, you'll need to find a nuclear geometry solution satisfying the EGM waveform appearing on screen. But before you attempt this, you'll need to resolve the many orders of magnitude problem for yourself. However, you can either utilise our solution as is, or you can utilise it as a guide to find your own pathway to the solution. At this juncture, I would strongly recommend that you review our solution in episodes 34 and 35 in order to get your head around what I'm talking about. Of course, the easiest thing to do is to utilise our solution as is. This will save you a lot of time. Assuming that you do utilise our solution as is, here we see the depiction of a classical transverse electromagnetic plane wave. You can see that the electric field wave propagates perpendicular to the magnetic field wave. You can also see the magneto-gravitic coupling wave. This denotes a theoretical area of research applicable to normal matter only, actively investigated by scientists interested in the concept of relating electromagnetism to gravity. I should stress that the relationship between magnetism and gravity is conjecture and nothing has been experimentally verified, only mathematically argued. However, I have included this possibility in the illustration because it applies to normal matter only and is a mainstream scientific area of research. This area of research is considered radical, but it is not fringe science. You can also see the electro-gravitic coupling wave. This denotes a propagating effect which inhibits the absorption and emission of gravitons into and out of the dark reservoir of quantum potential energy. Remember, we have defined one graviton as an entangled pair of conjugate photons. That is, the specific geometry of the element 115 nucleus generates a gravity A wave signal which inhibits the particle creation annihilation process associated with the zero-point field. In the simplest possible terms, element 115 inhibits the Casimir effect. Let's now quickly review what we're hoping to achieve. We postulated that element 115 acts as a quantum vacuum inhibitor, serving two functions. One of them is that it destructively interferes with the random emergence of conjugate pairs of virtual photons, that is gravitons, from the zero-point field. In other words, it suppresses the Casimir effect. Consequently, the distance between points A and B collapses to no more than 12 femtometers, which was the condition at the instant of the Big Bang and the condition of maximum permissible energy density. However, the obvious question is, why should space-time collapse between A and B? Well, let's have a think about it. We know for a fact that space-time does not naturally exist without the quantum vacuum, and the ground state of the quantum vacuum is the zero-point field. So, every cubic millimetre of space-time throughout the observable universe contains the quantum vacuum, and most of it is in the form of the zero-point field. Moreover, from previous episodes, we identified that a layer of unobservable reality exists beneath the zero-point field. If it didn't exist, then feeding energy to the Casimir effect from the quantum vacuum would violate the law of conservation of energy. We termed this layer of unobservable reality the dark reservoir of quantum potential energy. What is particularly important to note is the term potential energy. This tells us a lot whether we realise it or not. What do I mean? Let's use an analogy. We can consider the dark reservoir of quantum potential energy to act like a battery, powering the Casimir effect via the zero-point field interface. We all know from daily life that a 3-volt battery can be manufactured to any size. It can be the size of a button, or it can be much larger. Size makes no difference to potential energy. Similarly, physical dimensions make no difference to potential energy. Thus, if the Casimir effect between 2 points in space-time can be suppressed, that is, switched off in a manner of speaking, then the three-dimensional space-time between these 2 points cannot be said to exist. How so? Well, if the nature of the cosmos is a four-dimensional hypersphere, then if we suppress the fourth dimension by suppressing the Casimir effect, we must also be suppressing the other three dimensions too, because they exist at right angles to the fourth dimension. If the fourth dimension is missing per se, because its interface to three-dimensional existence has been suppressed by element 115, then three-dimensional space-time must also be absent. If this were not the case, then we'd be claiming that we can separate one dimension from the rest. This, of course, is ridiculous. If we remove the columns holding up a roof, the entire structure collapses. The same is true of 4D space-time. By collapsing one dimension, the other three dimensions must also collapse. Let's now summarise what we've learned. In this episode, we have identified some of the significant problems you'll need to solve in order to make interstellar travel a realistic engineering possibility within the next 200 years. Let's start by looking at the hypotheses to be tested. Firstly, element 115 generates a so-called gravity A wave, which can be amplified utilising conventional electromagnetic principles. Secondly, element 115 acts as a quantum vacuum inhibitor, suppressing the Casimir effect. And thirdly, element 115 facilitates reactionless propulsion, permitting interstellar travel. These hypotheses introduce the theoretical scientific challenges you'll need to overcome. Firstly, and most importantly, the problem of nuclear stability. Nothing can move forward without this being theoretically resolved. And secondly, you'll need to demonstrate in a convincing way that the right isotope of a stable element 115 atom generates an electrogravitic coupling wave, as depicted on a previous slide. To assist you in achieving this, we have offered the possibility that the resolution of the many orders of magnitude problem is the key to generating an electrogravitic coupling wave. Please review episodes 34 and 35 for additional phase state information. Finally, you'll need to overcome some important and difficult experimental scientific challenges. Unfortunately, these involve money, people and egos. Everyone is your friend until you want money, especially if it's money that doesn't directly benefit your electorate. In closing, once again, we stress that the contents of this episode are purely conjecture. The conclusions presented may be incorrect, so viewer discretion is advised.